In this video, we'll visually explore and prove the Pythagorean theorem. First, let's draw a large square and four identical yellow right-angled triangles inside it. Notice how these triangles form a smaller square in the center. Now, let's move the entire figure to the left and draw a similar setup on the right. We'll reposition the triangles to reveal the theorem's underlying geometry. The blue areas in both arrangements are equal, demonstrating the theorem. From the diagram, we see that the area of the blue square on the left is the square of the length of the hypotenuse, c squared. In the diagram on the right, the area of the blue square in the upper right corner is the square of the length of the longer side of the triangle, b squared. In the diagram on the right, the area of the blue square in the lower left corner is the square of the length of the shorter side of the triangle, a squared. The areas correspond to the squares of the sides of the triangles. This leads us to the elegant conclusion of the Pythagorean theorem, which states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. In this visualization, we observed the Pythagorean theorem, which states that the square of the hypotenuse is equal to the sum of the squares of the other two sides.